first of all, why have I chosen this topic? Well, naturally, I talk a lot to customers about Elasticsearch. Most of them store sensitive data in Elasticsearch. Could be PII data, transaction data from the financial sector or healthcare information, patient data and stuff like that. So sometimes very critical information. And my first question is always to the customers, how do you actually secure your Elasticsearch installation? And the answers, even from bigger companies, are sometimes very scary. Some companies just have it completely unprotected. Some companies say, well, we are behind a firewall. That's all we need because we trust our employees. And sometimes they have a VPN and a firewall, which is basically the same, to say, well, we're in a secured area and anything that happens inside our secure perimeter is inherently safe. So the basic assumption here is that you have something called a parameter, which is most of the time, let's say your data center, or could be your cloud installation, stuff like that, which is deemed to be trusted. So all the traffic that goes on inside this trusted parameter is basically deemed secure. And the outside, the untrusted part is the internet, where bad things can happen. So this is kind of the model that has been around for a long time. And the assumptions are that traffic from the outside cannot be trusted. Okay, that's basically a no-brainer. The traffic inside the parameter can be trusted. The access to the parameter can be controlled by the company. And that leads to the idea that VPNs, firewalls, and load balancers are basically sufficient to secure your infrastructure. Another idea is that at any point in time, you or your system administrator knows exactly who has access to what data in your parameter. So most of the time when looking at installations and infrastructures, the traffic inside the parameter, means, for example, the VPN, is oftentimes not encrypted. So there are a lot of companies that just don't run any end-to-end encryption. And the last assumption is that any security breach that might happen can be detected, and you can figure out what happened and who was breaking into your system and what data was affected. So the main question that I have is, does parameter security work, or does it still work? I mean, it has been around for some time. So at some point it was probably sufficient. But if it still works, why do we still suffer security breaches and data loss? So let's do a quick reality check here. And these are a couple of examples regarding data breaches, sometimes based on Elasticsearch, but not necessarily. Could be any other system as well. Could be, I don't know, could be Kafka, could be Hadoop, could be MongoDB, whatever. So this first one is from 2018. Was a data breach which happened at a company called Exactis, which lost 340 million personal records, including very sensitive information like addresses, age and gender of the children, home address, and stuff like that. And it was labeled like, it seems this database had pretty much every US citizen in it. So why did this breach happen? It happened because an Elasticsearch cluster was publicly accessible. It was completely unsecured and reachable via the public internet. So this is an example where the parameter is was not secured at all. The next one is from 2017. It's from Apple. So in this breach, companies working as distributors for Apple in China stole data from Apple's internal databases. So that means the attackers had access to this data. Probably they had to get access because they're business partners. So this is a perfect example of an attack that happened from inside your parameter. Another example is Best Western. They have lost customer booking details because of a hotel reservation system. I think its name is AutoClerk, which also contained name, date of birth, home addresses, travel dates, and so on. In this example, the Elasticsearch installation was run on AWS, and it hosted multiple clients. So it was a multi-tenant capable application. And last but not least, the data breach at one login. This is a very interesting one. This was also, it's not quite clear if the underlying system was Elasticsearch or something else. But as far as I understood, the way that this attack took place is that the company lost an AWS key to an intermediate host. So the attacker did not gain access to the original systems, like the original databases. But what the attackers did, because the database was a distributed one, is they just fired up another node. In Elastic, it would be an Elasticsearch node, which then joined the cluster, and then of course got data replicated to it. And in that case, the customers have been advised to change all passwords, all tokens, and all certificates. So this was a very major data breach, which shows that you don't need necessarily have access to original systems and hardware and operating systems for a successful attack. And then just recently, and it's also, well, it's actually not funny, but on the other hand, it affected us. So this is an email from our Floragun domain, which showed up in a data breach. And this, as you can read here, is again a publicly facing Elasticsearch server that exposed data. This was from February 2020, so that just happened recently. And it just shows that, yeah, this is an ongoing problem. And maybe it's not the problem of the people administering those systems, because I don't think that those leaks have been made on purpose. It's just that the landscape, the security landscape, really changed in the last couple of years. So let's take a quick look at what has actually changed. Well, first of all, the people or persons that need to have access to your system and your data one way or another has increased. So you're not only dealing with full-time employees, you're dealing with partners, you're dealing with distributors, freelancers, part-time contractors, and so on. The access to the data is not only happening from your main offices, but of course, remote offices and remote work has increased. And this is especially true now in times of Corona. I mean, everyone's sitting at home in their home office, but still need to have access to data one way or another. So this poses a big challenge on security. Alongside with that goes the explosion of devices. We're dealing now with laptops, smartphones, tablets. If you're employing freelancers, it's often bring your own device. So it's a lot of different devices that need access to your data. And of course, we're in the age of cloud computing. So I guess most companies run one or more cloud services in their infrastructure. So we have the cloud storage, we have microservices, software, platform, and infrastructure as a service, which basically means that you're outsourcing parts of your IT infrastructure and giving, well, control to your cloud provider, your cloud vendor. And then, of course, containerization is going to continue. So that's Docker, that's Kubernetes, very dynamic infrastructures where you can spin up containers and pods and spin it up, spin it down as required. And the last thing is IoT. So there's also an explosion of devices that can actually generate data that needs to be stored securely somewhere. So that means if we're looking at modern systems, you need to have, of course, support for containerized environments like Docker and Kubernetes, cloud platforms, centralized identity providers, often coupled with federation, like Active Directory, Keycloak, Okta. So we're basically talking about decentralized systems and, in that case, clusters. And of course, CearchGuard supports all of those features. So the question is, if we're looking at this parameter-centered approach again, and if we take into account that we now have the explosion of devices, remote work, software as a service, platform as a service, and stuff like that, the question is where's the trusted parameter now? And well, the simple answer is there's no trusted parameter anymore, and everything has to be deemed untrusted. And this is where the term zero trusted network stems from. This is a concept that originally, I think it originated at Google, and the main paradigm shift is that the assumption is that no traffic can be trusted anymore, regardless where it originates from. It doesn't matter if it's an outside request from somewhere, from someone in home office, for example, or if it's originating from your own data center because an admin logged into a system. Doesn't matter. Every traffic has to be deemed untrusted. Also, no application can be trusted anymore. No IP range can be trusted anymore. So the traditional firewall approaches based maybe on IP rules and ports and applications are flawed. And of course, no user can be trusted. Of course, this includes inside and outside personnel. Regarding this particular topic, there's another war story. This is from a hosting provider from the Netherlands, and they actually let a system administrator go, means they fired him. And this system administrator, out of revenge, decided to delete, well, basically all the data, including all the backups, which led to the bankruptcy of this hosting company. So one person, from the inside can do a lot of harm. So that means you can't have any unencrypted traffic anymore anywhere, not even inside your own infrastructure. So the goal should always be to have end-to-end encryption. Second point is you have to move the security to where the data lives, which means there must not be, of course, no unsecured service. But that also means that traditional solutions like, for example, putting a proxy in front of a service, let's say an Nginx proxy, also doesn't work anymore. So the kind of new way of thinking is think of micro parameters, which means that the security solution for your service, for example, database or whatever, has to be implemented as tightly with this particular service as possible. So once you move your service around, let's say you shift it from one machine to another or from one network segment to another, the security solution should automatically move with it. The third one is, this is very important to me. So you have to assume that the attackers are already in your network. So the traditional way of thinking the hackers are somewhere outside, somewhere on the internet, doesn't work anymore. An IBM study already in 2016 revealed that over 60% of all attacks are originating from the inside, not from the outside. And we're having, now it's 2020, so I guess that number increased a lot. Then of course, apply a least privileges strategy. And last one, inspect and log all the traffic that's going on in your network. So now let's have a look at a couple of real-world attack scenarios and how we can shield you from those attacks with SearchGuard. So first, let's talk about encryption. So this is the scenario that I was talking about before. So you have a data lake. In our case, it's Elasticsearch inside your VPN. And the thinking is that you can actually terminate TLS once the request has reached your perimeter. This is often done by a proxy or by a load balancer. So the thing is that because we have to assume that an attacker is already inside our network, once the traffic is unencrypted, and even if it's just from a proxy or load balancer to your actual data source, this data, of course, can be accessed and can be sniffed. The same is true if you have a distributed system like Elasticsearch, where you have different nodes talking to each other. So even if the traffic is encrypted until it hits your Elasticsearch cluster, if you do nothing, then the traffic inside your Elasticsearch cluster, again, is unencrypted. So let's say you're querying one particular node, so you're firing up a query. So this node needs to talk to many other nodes in your cluster in order to execute the query and collect the final data. In that scenario, this traffic between the nodes is also unsecured, which means that I can, if I'm inside the network, I can again sniff that traffic. It's a binary wire protocol, which can be, of course, analyzed. So once I'm inside your network, again, I can sniff the data that's going back and forth in your cluster. And the third one is the one that I already mentioned. What I can also do is trying to attack your cluster by just firing up another Elasticsearch node, which means that data is getting replicated to that node. And since I'm in control over that node, I'm then in possession of that data. Now, how can we solve the problem? Well, with SearchGuard, one of the biggest, let's say, building blocks of our security solution is TLS. So we have TLS everywhere in Elasticsearch. First of all, on the HTTP layer, I think that's quite clear. So whenever you query your data with curl or a browser or whatever, we apply TLS. Which makes sure the data is encrypted and also that the data is tamper-proof between the client and Elasticsearch. And in addition to that, we have TLS on the transport layer. And this actually shields you from data that's being sniffed inside your Elasticsearch cluster. And it also makes sure that only trusted nodes can join the cluster. So this is the first level of security. As you can see here, you can run and configure TLS with your own certificates. I think that's pretty straightforward. There are three things that I want to make you aware of. SearchGuard also supports hostname verification, and SearchGuard can also resolve host names in your certificate. So what does it mean? It means that whenever you install a certificate, SearchGuard makes sure that the host name in the certificate, in the sound section of the certificate, actually matches the host name of your Elasticsearch node. And in addition, you can also switch on to resolve host names, which means that SearchGuard can perform a DNS lookup of this particular host name to make sure it actually resolves. So even if someone tries to attack your installation and tries to, spoof a certificate, even if this, should succeed with hostname verification and DNS hostname resolving, an attacker would also need to get control over your DNS, for example, which is pretty hard at the same time. And we also control the cluster formation with TLS, which means only nodes which have a trusted TLS certificate are allowed to join the cluster. So we have a list of trusted nodes, which we can configure in our Elasticsearch YAML file. I can work with wildcards and regular expressions here. So I can make sure that only certificates that match or are in the list of trusted nodes are accepted. Okay, so if we have a look at how this looks in SearchGuard, I have a demo running here. This is based on Docker, which runs Kibana and Elasticsearch and SearchGuard. And so the first thing is if we try to access, and I'm using a fresh incognito window here. If we're trying to access Elasticsearch without HTTPS, then of course this will not work because TLS is enabled on all layers. Of course, if I access it with TLS enabled, and I'm using admin account here, then access is granted. And I can also have a look at the actual SSL settings that are in place. So I can see here, at the moment, we're running TLS 1.2 with this particular cipher suite. So SearchGuard supports all modern cipher suites, including elliptic curve ciphers. We also support TLS 1.3. And you can actually also limit or define what kind of TLS versions and what kind of ciphers you want to allow. So you can make sure that you also only allow safe TLS versions. For example, you would switch off TLS 1.0 and 1.1 because they're not secure anymore. And you can also control or allow only strong ciphers. So this is kind of the building block of the SearchGuard security solution. So the next one is, I was talking about microparameters. So you should actually move the security solution as close to your system as possible. Why? Let's have a look at this particular example. This is a traditional flawed setup where one sets up a proxy, could be, for example, Nginx, and implements ACLs, access control lists, based on URLs. And for example, I have set up a role and I want to disallow access to an index called MyData. So a naive approach could be, well, I have the index name in my URL, so I can inspect it, and I can then decide whether I should allow or disallow the access. In case of Elasticsearch and also other systems, this approach will really not work, because if you're not running inside Elasticsearch or directly connect with Elasticsearch, then you have the problem that based on the URL, you cannot really say which final indices are queried. In Elasticsearch, we have something like an index alias. I can use wildcard in index names. We have date math-based index names. And of course, we have the bulk in the multi-get and multi-search APIs. So by just looking at the URL, I cannot really tell which index or which data is being queried. It's just not possible. So since SearchGuard is an Elasticsearch plugin, we tightly integrate with the inner request flow of Elasticsearch, which means that we inspect all the requests that are coming in from outside and that are distributed inside the cluster. So whenever we have a request, we can resolve the index name in the request to the underlying concrete indices, which means when I'm using a wildcard, what SearchGuard is going to do, it has a look at the actual indices in your cluster, and then it maps the request to those concrete index names. So if you're accessing an index with its real name or an alias, or if an index is contained in a wildcard search, it doesn't matter. We will resolve all the indices and then apply the permissions accordingly, which means that the access control cannot be bypassed. The least privileges defaults. This is also a very interesting topic. So when we have designed SearchGuard in the first place, what we wanted to avoid is we wanted to avoid default roles and default users. So some applications are shipped with, you know, the infamous admin default account. Yeah, of course, you should change the password immediately, but we all know that's probably not going to happen. So we didn't want to ship SearchGuard with any of those default roles because we wanted to apply the least privileges approach, which means that we wanted to we want to make sure that the roles that are defined in SearchGuard have the least privileges and are as granular as possible. So when you install SearchGuard the first time, there are actually no roles, no permissions. You can decide to import some demo roles for proof of concept or for playing around, but when deploying it to production, there are no defaults. So instead of shipping with a default, again, SearchGuard is relying on TLS. And that means that the infamous admin default account is replaced by a configurable TLS admin certificate, which is again kind of which gives you full access to the cluster, but it's your own certificate that grants access and not some default admin account. And regarding the least privileges approach and the fine-grained access control, SearchGuard is able to protect your data on cluster and index level, document and field level, and we also offer field anonymization on the fly, which gives you full control over each aspect of your data. So let's have a quick look on how that works. So I have my demo system up and running, and I'm just quickly logging in with the admin account first to show you how the data looks from an admin point of view. So I have two main data sources or main indices. One is containing personal data like first name, last name, and the other one is an index containing log data. So if you have a look at this data here, you can see usual stuff like address, age, designation, first name, last name, and stuff like that. So what SearchGuard can now do is protect this data, of course, in this particular index, but it can also filter out documents from that index and also fields based on a user's role, which makes it possible to implement very fine-grained security controls. So if I log in with a second user, so I'm using a second browser here, and I'm having a look at the very same data in the very same index. Okay, so I had my session timed out. Then you can see that some of the fields are actually filtered out because of my permission settings, and I'm only able to see parts of this data. So let's have a look at the actual role definition that implements these security controls. So I'm going to the SearchGuard admin page, click on the role. It's that one here. And as you can see, for each and any role, I can define permissions on cluster level. These are permissions that control access to data over your complete cluster. I can implement index permission, and I also can control access to data in Kibana. But let's have a look first at this index permission here. So that means this particular row, make it a little bit bigger, has access to this human resources index. And if I have a look at the field level security, I only allow these 4 fields: designation, first name, last name, and salary. So let's say I want to change that. Let's say I don't want to display the salary anymore for this particular row. And let's say I want to also anonymize, let's say, the last name. So I can just do it here, save my row. It's updated on the fly. So the the changes take effect immediately. And if I go back to my other role here and have a look at the changes, then you can see that the salary field is actually gone and my last name is now anonymized. Now, field anonymization is not only, we can not only do it by replacing a field value with a hash. We can also work with regular expressions, for example. So I have another index called logs. Let's quickly change the user here. Let's have a look at this data. So in this particular role, I have defined to change or anonymize the IP addresses in my log file. Let's see. The data is a little bit, yeah, here it is. So if you have a look at the IP field here, so in my index in Elasticsearch, this is stored as a clear text value, of course. But with this row that I have in place, I have implemented a regular expression to actually remove that IP addresses with access. Could also be applied to credit card information, for example, to only display the last 3 digits of a credit card, and so on. So this is the access control on index level, document, and field level. Now, another part of the security infrastructure is the audit logging. So what you want to do is you want to have complete knowledge and control over what's going on in your cluster. So for example, you want to detect if someone tries to implement a brute force attack, just trying out different passwords. If a user tries to break into your cluster by, for example, spoofing headers or using invalid TLS certificates. You maybe also want to know who has accessed data in your cluster. This is especially valuable if we're talking about compliance regulations like PCI or GDPR. So you want to track who of your employees has accessed, let's say, a credit card number or an email field in clear text. And the third one is you want to track how your security configuration changes over the course of time. Now, why do we want to have an audit trail about all those data? In case you suffered a security breach, it's vital that you know what data has been accessed by whom, where the attack originated from. So you want to gather as much information as possible to analyze this breach or this attack. So CearchGuard offers an extensive audit trail module as well, where we can track a lot of events that are, basically any event that's going on in your cluster based on the security configuration, including stuff like failed login attempts, TLS exceptions, spoofing attacks, but also events like a document read access or document write access. So you can create an audit trail of everything that's going on in your cluster, including security configuration changes, and you can store that information at various endpoints. In Elasticsearch, we support Kafka, webhooks, and a lot of other endpoints. So let's have a look how that looks. So for this, I'm gonna switch to this one here. So you can actually configure the indices that we log to. No, sorry, that was the wrong one. Just give me a second. Okay, so I have to configure another index pattern. So let's just quickly do that. So I'm gonna change my tenant here and add quickly my index pattern. And I'm gonna have a look at all the audit log indices. So you can actually configure which audit log event should be added to what index. So in my case, I have 3 different ones: default, internal, and read-write. And I just want to show you a couple of events that we can record with the audit log module. Okay, now we have the index pattern. So here you can see the different categories that we can track. Let's have a look at the failed login, for example. This is the easiest one to explain. So since my system is running, I already have a couple of those events. So I can actually track and expect them. I can see from which IP address it originated. Of course, we have a timestamp, and we have all the request headers that were contained in this request. Another type is, for example, let's just clear that one here, are events like document read, which I can use to track which account has accessed what document. So let's have a look at that one here. So what I'm doing here is I'm monitoring my human resources index with all the personal information in it. And this is an example of an event where a user, in that case it was the admin user, accessed this particular document on REST level. And this particular user has accessed this data. So you can track data access. You can also track, of course, changes of data. So whenever someone changes a document, deletes a document, adds a document, this can be tracked as well. And the last one is we can also track our configuration changes. That would be, oh, sorry, these are read events. I want to focus on the write events. So, for example, here you can see that we had a configuration change to our security configuration. We can see the actual change values in JSON patch format. We can also log the complete request body if we configure SearchGuard to do so. So I can see what configuration, security configuration has changed at what point in time. Okay, so the last thing I want to show you is how this can all be monitored. Because, I mean, having audit trails is all good, but the question is, if we record audit events and we store it somewhere, who's going to monitor it? Who's going to be gets notified if something happens? For example, if we have a brute force attack, for example, if we have anomalies in our data, so someone is changing a lot of data or is deleting data, or if someone is actually trying to bring our system down by performing a DOS or DDoS. For that, you can use Signals, which is a monitoring and alerting solution for Elasticsearch. You can monitor your cluster for, of course, data anomalies, like peaks, data peaks, for example, or changes in percentages. You can monitor the cluster health itself. If required, you can also connect the monitored data with external data sources, which means you can pull in data from other systems as well. And then, of course, you can generate actions and alerts from it. Ship alerts to email, Slack, PagerDuty, Jira, or Microsoft Teams, which is coming soon. And you can implement escalation levels with that. So the first thing that we just gonna have a look at is if we have our access our alerting. These are just a couple of demo watches that we already have implemented, but let's have a quick look at how that looks like. So let's say I want to have an audit log watch, which watches over my events in my audit log, which are generated by the SearchGuard audit log module. I could just select it here. I need to select a timestamp. And here I can see the number of events. Now, in a real world scenario, of course, you would this would be a little bit more complex. So you wouldn't just have a look at the raw events. You would group them by event type, for example, failed login. You would group them by account, for example. So you can detect if the number of failed logins for a particular account suddenly spikes, then it might be someone trying to brute force attack this particular account. But in our simple case, I'm just going to monitor the raw values of my audit log index. And I can just define if the count over all documents is above, let's say, 20, which would be my threshold. Let's say 10 for the sake of this demo. Then I would like to get an alert. I can add an action here. In this case, I want to get a notification via Slack. So I have my Slack account already configured. And then I can just create this very simple watch. And if I go to my account here, you can see that this event here has popped up. So we have 37 events in our audit log index, and I got a notification via this Slack watch. So this is the easy way of configuring watches. We have 3 different modes how you can actually define watches. Just gonna show it very quickly. The first one was the graph mode, where I can operate directly on a graph. The second one is the so-called blocked mode, where I can define the different steps that my watch should perform when scanning for data anomalies inside my cluster. And the last one is the raw JSON one, which gives you the most control over the watch, but of course is it's just raw JSON. So these are the 3 modes we support. So you can use the signals to monitor, for example, your audit log index. Of course, you can also monitor other indices, like if you're just storing plain old log files, can do that as well. And as the last one, you can also use it to actually monitor your Elasticsearch installation itself. So here I monitor the memory consumption. I can also, of course, store it in Elasticsearch and implement notifications. But what I can also do is I can add a dashboard based on that data, which would then look like that. So I can implement a monitoring of the system health of Elasticsearch and other systems as well. So to very quickly wrap it up. So our zero trusted network approach for SearchGuard means that, first of all, we have a solid TLS layer with hostname verification, DNS lookup. We support certificate revocation lists, TLS client authentication. So everything TLS is supported by SearchGuard. We have the role-based access control with a least privileges approach. We don't have any defaults that we that we ship with. You can control your data on document field level. You can filter fields. You can anonymize fields. So this gives you total control on your data. And with the audit log module, especially in combination with the alerting, you can track access to your data. You can monitor your data in your cluster for anomalies. And you can then implement alerts, which means notifications via email, Slack, PagerDuty, and so on. So your main takeaway from this presentation should probably not any very specific technical detail. I think the main takeaway should be trust no one and assume that the attacker is already inside your network. Thanks very much. And I'm going to hand back to David.